me. Let's start with this, the blue one. Okay, so we have the cost in dollars of producing X units of a certain commodity. Of course, I will rearrange it as 0.0007 x cubed minus 0.02 x squared plus 2x and plus 920. Find the marginal cost function, part A. This is C prime of x, which is the same thing with A. A and B are the same, and explain its meaning. So this will be 0.0021 x squared minus 0.04 x plus 2. And what is the meaning? It predicts the cost of the next item. It's the rate of change, right? It's the rate of change of cost with respect to number of units produced. But literally, so it's the rate of change of cost with respect to the number of units produced. But basically, it predicts exactly the cost of n plus first item, or x plus first item. Let's use x because it's just x in here. X plus first item. Okay, so now in part C, so A and B are the same question. In part C, we are asked to compare C prime with the cost of producing a 101st item. So we have to find C prime of 101, and we also have to find C of 101 minus C of 100. And compare these two. This is the exact cost of producing a 101st, right? From subtracting from the difference, exact difference, the cost of 101 minus the cost of 100. This will give us an exact cost of the 101st item. But this one, using the derivative, will give us an approximate cost. And they should be quite close. Why they should be quite close? Because we're only talking about 1 unit difference. So if this is 101 and this is 50, and you want to plug in C, or you want to plug in 101 in the cost, they will be hugely different. But if we're only talking about 1 unit difference between 101 and 100, you'll see that in the next section in 3.10, what I'm talking about right now. So C prime of 101, because the change is so small, just 1 unit between 100 and 101, these will be very, very close. So I would plug in the cost function in the calculator and the derivative and plug in what I need. So let's see, the cost is 0.307 x to the third, and then minus 0.02 x squared, and then plus 2x, and then plus 920. And the derivative was 0.0021 x squared, and then minus 0.04 x, and then plus 2. And I go to the table, I have to reset this all the time. Okay, and I plug in 100, and I plug in 101. And I only take what I need. So for C of 101, and of course, you should go back and highlight it and see what the number is, because it truncates, of course. So the cost of manufacturing the 101st unit, I will say, is 1639.19. The other one for 100 is 1620, and we'll find the difference in a second. And then we are interested in only this, 19.382, or not just 19.38 dollars per unit. Okay, so we got 19.19 dollars per unit. As expected, they're extremely close. 19.38 we get for the derivative, And the exact difference is 19.19. Okay. Any questions? Any questions on this problem? Any questions? Is this okay, everyone? You can just determine the difference. You don't have to copy it, right? Is this okay, everyone? Okay, so let's look at the other one then. So particle moves with a position function given to us. Of course, time is greater than or equal to 0. At what time does the particle have a velocity of 20? So first of all, we have to find the velocity. V of t is s prime of t. And that will be 4t to the third minus 12t squared minus 40t and plus 20. So in part A, we have to solve 4t cubed minus 12t squared minus 40t plus 20 equals 20. At what time does the particle have a velocity of 20 meters per second? So, of course, I will subtract 20 from both sides, and I will divide both sides by 4. And I get t cubed minus 3t squared minus 10t equals 0. Obviously, I will pull out a t. I cannot divide by it, because this is a polynomial of degree 3, polynomial equation. I expect 3 solutions. So now this is t minus 5, and t plus 2, and we have 3 solutions. T equals 0, t equals 5, and t equals negative 2 seconds. So at 3 different times, the velocity is 20 meters per second. At 0, at 5, and since the last one is negative 2 seconds, we will have to disregard it. And part B, at what time is the acceleration 0? In part B, the acceleration is the second derivative of time or the first derivative of the velocity. So I have to differentiate again. And let's get, what was this? 12t squared minus 24t and minus 40. And the question is, when is this 0? So 12t squared minus 24t minus 40 equals 0. I will definitely divide by 4. So this is 3t squared minus 6t minus 10 equals 0. You either attempt to factor, I don't know, so it's 30, may not be factorable. So you can use the quadratic formula. So then t equals 6 plus or minus 36 minus 4ac plus 120 over 2a. We put that in the calculator and we get, let's see what we get. And parentheses for the top, I have 6 plus the square root. I will put parentheses. So 36 plus, oh, I can add that. So it's, what is it, 156? And divide by 6. 156, yeah. And then the other one, keeping in mind that the answer cannot be negative. And minus. Okay, so then time is 3.08 seconds, and time equals negative 1.08. I shouldn't even write the other one. Any questions on any of this? Any questions? Pretty straightforward? Yes? Say it again?
Can you actually sit down on the paper? Can you like move it down or?
Is it okay? Do you have any questions or?
No.
Okay. Yes. Everything. Any questions? Anyone? Any questions? Okay. So let's go back to 3.9. We only looked at through 2 different problems. Let's move on. Yes. Brayden, you had a question? Brayden, you were working on a problem? Because you wanted to ask about 3.9?
I wasn't working on it. I just wanted to go over it, but if we're doing other problems.
Oh, absolutely. Oh, yeah, that's not enough. Yes. On page 249, I would like to look at the problem with the cone, the gravel, blah, blah, blah. So let's take a look at this one. So obviously this is a cone, And it says that gravel is being dumped from a conveyor belt. And it's dumped from the conveyor belt, and it forms this pile in the form of a cone. And we are told that that happens at a rate. I have to read the problem. I'm going to write these items, the list of things that we need to do when we have to solve a related rates problem first. Let's do that. I need to do that first. So related rates, steps to follow whenever we deal with related rates problems. Number one, read multiple times. I don't know how many times. It depends till you understand what is given and what the question is asking us to do. Number two, take notes. And like we did last time, you may want to draw a figure to see what's happening. Number three, identify what is given and identify what is asked. Identify the given info. Number four, state the question clearly. Number five, create an equation or a relationship, preferably an equation. State an equation that links the given info to what it's asked. Given info to the question. So for example, if I'm given the rate of change of distance with respect to time, I may be asked to find the rate of change of some other distance with respect to time. That will be the question, and that will be the information. 6, differentiate implicitly. Both sides, of course. Both sides of the equation implicitly. And the last step, I would say, plug in the numbers. Just at the very end. Very end. 7, plug in the numbers. So read the problem multiple times. Take notes, and basically, if you need to, draw a figure like we did. Identify the given information. Identify the variables. Identify what is given to us. Number 4, state the question. Identify what we are asked to determine. State the question clearly. If we determine a distance with respect, a rate of change with this distance with respect to time, or volume with respect to time, or area with respect to time, that will be our question. State an equation that links the given info to the equation. Because if I don't have an equation, if I can't create an equation, then there is nothing I can differentiate. Then differentiate both sides of this equation, implicitly. And at the very end, plug in the numbers. And if you want to add one more, state the answer clearly. Clearly. Now, I will put in parentheses, measurement unit. Please do not forget the measurement unit. Please do not forget the measurement unit in the final answer and throughout. Okay, so now we are ready to read this problem. It's problem 27 on page 249. And we are given a figure this time. Gravel is being dumped from a conveyor belt at a rate of, I'm taking notes, 30 cubic feet per minute. 30 cubic feet, is it? Did I say cubic? Yes, I did. Per minute. I don't know what this is. I have to establish what this is in a minute. So it forms a pile in the shape of a cone whose base diameter and height, they say, are always equal. I'm taking notes. So I draw that figure. This is the base diameter, and this is the height, base and height. Or if you want to write it as D as diameter, I don't want to because of DD. I don't like DD in there. It depends on what we're facing, but I'm trying to avoid denoted anything by D. Okay, I will say B equals age at all times. So this is the first piece of information. This is the second piece of information I have. They are always equal. How fast is the height of the pile increasing when the pile is 10 feet high? So here is my question. How fast is this increasing when the height is 10 feet? So what am I asked when the height is 10 feet? So what is this and what is this? Let's read the problem one more time. So we're dumping sand and from a conveyor belt. And the pile that is created is in the form of a cone. That's the shape of a cone. And the base of the diameter and the height of the cone will always stay the same. The volume will increase, but the length of the diameter and the height will always be the same. Now the question is, how fast is the height changing when the height is 10? Yes, please.
What's the problem number?
Oh, yes, I'm sorry. 27 on page 249. Sorry about that. Okay, so we are given the rate of change. It's a rate of change, 30 cubic feet per minute. I need to identify what this means. If I can't identify what that means, then I will not be able to start the problem. So what is it?
Which volume is being added every second?
True, but what do I write here?
dV
Say it again.
dV over dt.
Exactly. This is the rate of change of volume with respect to time. How do I know? Because it's measured in cubic feet per minute. So cubic feet can only relate to volume, and minutes can only relate to time. Excellent. Very good. So now let's see what we are asked here. Excellent. Thank you, Chris. This one. What is this? What are we asked this time? dH over dt. Indeed, this is our question. So we want to find the rate of change of height with respect to time in a specific situation. So let's go quickly through all these steps. We read the problem several times. We did take notes. We did not have to draw a figure out of the blue because we already were given that. We identified the given info. Yes, we were given the volume, the rate of change of volume with respect to time, and we were told that the height and the base will always equal, and the volume will increase, but those two will be always related like that. They are the same, this length. State the question clearly. We did. This is the question. The rate of change of the height with respect to time, okay? We have to state an equation that links, or I should say an equation, or maybe a function, whatever, that links the given info to the question. Where is my starting point? And then we differentiate, and then we plug in the numbers. Which numbers? This, and anything else. So we cannot plug this in at any point in time before we finished differentiating implicitly. Or just differentiating, depends on what we have. But we cannot plug in a number till the very last step, right before we state the answer clearly with a measurement unit. Okay, So we are at the stage in which we are trying to discover a relationship between what is given to us, which is the rate of change of volume with respect to time, with some condition that we have, and the height. So what do you think we will start with? Just give me your thoughts. Anything, any idea? Say it again.
The volume of cone.
Very good. The volume of a cone. Let me refresh your memory. So maybe this will trigger a memory for the future. So, true. So this is a cylinder, right?
Yes.
So the area of the base times the height is the volume of the cylinder. Area of the base is pi r squared, right? And multiplied by 8. Pi r squared times 8. Easy to remember, the volume of a cone is 1/3 of that. If you would like to remember it like that, you don't have to. But it's 1/3 of the volume of cylinder. And since we know 1/3, pi r squared h. Now I would like to stick with my variable. So this is what, that's okay. This is the general formula. So now we're going to plug in what we have. Don't change anything. That's the general formula for the volume of a cone. Okay. So then, at this point, I will write that our volume, in this case, is pi over 3. What is the radius? 1/2 the height. That's perfect. We can say that. It's even better. Perfect. So 1/2 times the height, everything squared. And what is the height? Well, height. Very good. So we continue simplifying this. So we have pi over 3 times h squared over 4 and times h. And the simplified volume, now we can say it only has one variable in it in this case. So the volume is pi divided by 12 times h to the 3rd. So what is this again? Is this. State an equation that links the given input to the question. So we stated an equation that links what we were given to our question, which is the rate of change of h with respect to time. At this point, I reach this part in which I have to differentiate. And why? Yes, please, Brady.
Where you have the 1/2 h in parentheses, why you also have times h on the outside?
Because this is this, and this is this. Is that okay?
Then why is it 1/2?
Because the diameter equals twice the radius. So if I want the radius, I have to divide the diameter by 2. And the diameter is the same with the height. Is that better? So that's why we replaced the radius by half of the height. Or half of the diameter. But I didn't want to use two different variables. Because
So that's 1/2 pi squared?
This one.
Yeah.
So this is the diameter. And this is the height, and they are the same. So if I want to determine this piece, which is the radius, I will say the diameter divided by 2. But I can also say the height divided by 2 because the diameter and the height are the same.
Okay.
So that's the reason why we replaced in the formula the radius by 1/2 times the height. Right? So the radius is 1/2 times the height, or the height divided by 2. Is that okay? Everyone? Thank you for asking, because other students may be confused too. Is the rest clear? Everyone? All the other steps are clear? Yes? Okay, perfect. What do we do next? One more time, we'll reach that stage, number 6. We differentiate both sides, and remember what is v and what is h. Are they variables? Are they functions? What are they? They are functions. Both are functions with respect to, or functions of, exactly. So we differentiate the left-hand side and we differentiate the right-hand side. What will you say about the left-hand side?
dv.
Indeed. What will you say about the right-hand side? 3 comes in front, 3 pi divided by 12 times height squared times, that's what we are after. I can simplify by 3, and I am going to solve for dh over dt. So let's write it one more time for everyone to see. So this is pi h squared over 4 times dh over dt, and we are solving for this. We are multiplying both sides by 4 over pi h squared. So dh over dt equals 4 over pi h squared times dv over dt. Only now we can say when h is 10 feet. And all we have to do is plug in the numbers. So I was solving for dh over dt, removing that number or constant or function, whatever it is in front, multiplying both sides by 4 over pi h squared. So now we can plug in the numbers, and I think that this was 30, and this is 10 squared, which is 100. So the answer then will be 4 times 30 over 100 times pi. I will simplify and by 2. So I have 6 over 5 pi. I will put in the calculator and get a number. So 6 divided by pi and further divided by 5. 0.382. 0.382. Without measurement unit, it doesn't mean much. What is the measurement unit? Excellent. Thank you, Emily. Indeed, feet per minute. So these are the steps that we need to follow in solving any related rates problem. Yes, please, Ricky. Say it again. Yes. Any questions? Any questions before we choose another? Do we feel a little bit better now about related rates? I know we only did 2 problems last time. That's far from being enough. Okay, so let's look at problem 15. Any questions? Any questions? Remember the steps. One more time. We read the problem several times. We take notes. We draw a figure if we need to. Yes, you want me to check the number?
Just the answer on 6 divided by 5 pi.
Yes. But you have to put parentheses.
Oh, okay.
Did you put parentheses around 5 pi? Then the calculator did something else.
Okay.
That's why what I did was 6 divided by 5 and the answer divided by pi.
Okay.
Or if you don't write it like that, then you have to put parentheses. If you don't put parentheses, the calculator will do this. 6 divided by 5 and the answer will be multiplied by pi. Be very careful. Parentheses are crucial. Very good. Other questions? Please ask if you have anything. Yes, please, Brayden, go ahead.
Where does the times 4 over pi h squared come from?
You mean this one? This one?
Yeah, the second one, where it's multiplied by.
Yeah, so I had pi over 4, so I had pi h squared over 4, this one. Is
No,
that
the one to the right?
this
Yeah,
one?
that one.
But I wanna solve for this, and I wanna remove it from here because I'm solving for dh over dt. So in order to solve for dh over dt, I have to flip this. I have to multiply by 4 over pi over h squared to get a 1 in front. But if I multiply it on this side to get a 1, I have to multiply it on this side. So I multiply both sides by this. Or if you can say I divide by it, which is the same thing. We are solving for this. This is our variable.
Okay.
So I have to get rid of this multiplying by the multiplicative inverse,
Okay.
both sides. Is that better? Good. Other questions here? Anyone? Please ask. Anyone? Okay. So I was saying, let's summarize again. These problems are not trivial problems. And there are a lot of steps that you have to think of. One more time. Number one, I read the problem. Maybe more than one. Maybe 3 times. I don't know. Depends on the problem. Number two, I take notes. I draw a figure. If there is one, that's fine. If there isn't, I have to come up with something. Then I have to clearly understand what is given to us. Then I have to clearly understand what is asked of us. Then I have to come up with a relationship between what is given and what is asked for us to determine. Then once I have that equation, then I differentiate both sides implicitly, like in this case, right? And then I plug in the numbers. The numbers are the last step before I state the final answer. Unless there is something that doesn't change, then I have to use that. But if it's something that changes and so every time you read a problem that is a related rate problem, you have to, when it says how fast is the height, blah, 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 increasing, when, after the word when, you have to disregard everything you read till the last step of the problem, of the solution. When it says when, completely forget this number. You can never put it in anywhere till you get the derivative. And only then you can plug it in. Is that clear? So after the word when, disregard the rest till the very last step. Okay, so let's read problem 15. Same page, or maybe not. Let me see. No, 248. Let's read the problem. 2 cars start moving from the same point. Okay, so here's the point. They start moving from the same point. One travels south. South. I already started by, once I'm reading the problem, I already started identifying the variables or what is given to us. I already started drawing a figure, so the first few steps can be condensed into one. One travels south at 60 miles an hour, and the other travels west at 25 miles an hour. Okay. At what rate is the distance between the cars increasing 2 hours later? So this problem does not have the word when, but it's implied. At what rate is the distance between the cars increasing when the time passed or 2 hours passed? So this is implicit. So the word or the key of 2 hours can never be put into play till the very last step. It's exactly, it doesn't have the word when, but it's implicit. It's when time or 2 hours pass. Okay, so be careful with that. Good. So let's say this is the scenario. So these are the 2 cars. One is going from this point, one is going south, and the other one at a slower rate is going west. And then I say stop. And I measure the rate of change of the distance between the 2 of them. But I have to plug it in something. And if I don't have the derivative, then I can plug it in anything. So they are going in respective directions, one south and one west. So I'm going to call this distance W. And let's read the problem one more time. And let's see what we are given, and let's see what we have and what we have to determine. One more time. 2 cars start moving from the same point. One travels south at 60 miles an hour. What is 60 miles an hour? And you can say, wait a minute. Well, let's say I'm going to denote this by X, and I'm going to denote this by Y. What is X? X is the distance covered by car 1. I'm going to call this car 1. What will Y be? Distance covered by car 2. I'm going to call this car 2. So they start moving from the same point. One travels south at 60 miles an hour. What is 60 miles an hour? Yes, it is speed, but in our context. Velocity, speed. Good. What is it? What do I denote by 60 miles per hour? What does this represent? Right. In this case, it's y. dy over dt. Exactly. This is the discovery process. I identified what 60 miles per hour represents. Okay, now let's look at the next one. So it says, and the other one travels west at 25 miles an hour. What is 25 miles an hour? Of course. This is indeed dx over dt. Okay, so let's go back to the list and see what we covered already, what we did already. We read the problem twice. We took notes. We drew a figure. We identified the given info. Yes, we did. We identified the given info. We identified the question clearly. Not yet. That's where we are. So what is the question? Let's read the question. At what rate is the distance between the two cars increasing 2 hours later? What are we really asked to determine? This is state the question clearly. dw over dt, and it says when t is 2 hours. So we identified the question clearly. Now we are in step 5. We want to state something that connects the information given, and then we want to differentiate. Good. So let's look at this. What do you conclude? What is this? Good. So what would you tell me to write, please? Anyone?
X squared plus y squared.
The Pythagorean Theorem, the sum of the legs squared equals the hypotenuse squared. Very good. We have discovered or determined the equation. So now we have an equation or a relationship or a link between the given info and the question. Now we want to differentiate implicitly. Ready? Can anyone differentiate implicitly? Very good. Plus? Perfect. Thank you, Emily. This is differentiating the given equation y implicitly, because I didn't solve for any. I didn't solve for x, I didn't solve for y, I didn't solve for w. Good. Obviously, I will divide both sides by 2, because all of these terms have 2 in them. And now I look at the problem or the question, and I know I'm asked to find dw over dt. This is my concern. This is my only concern here. I'm going to solve for it dividing both sides by w. So dw over dt equals x dx over dt plus y dy over dt divided by w. Where are we again? We finished number 6, item 6. And now in item 7, we're ready to plug in numbers, and then we state the answer. So then I will say only now, sorry about that.
Well, it's fine.
So only now I can plug in time to equal 2 hours. But you can say where? You have to determine the rest of the quantities. Yes, that's true. So I have to determine x, which is the distance after 2 hours. I do have the x over dt, it's given in the problem. I do have to determine y. I don't know the distance covered by car number 2 in 2 hours. I have to determine it. I have the rate of change at the speed. Yes, I do. It's given in the problem. And do I have w? No, I don't. But that's not a problem. I will take the square root from both sides and replace this by the square root of x squared plus y squared. So this becomes the square root of x squared plus y squared. Let's write it one more time. So dw over dt when time is 2 hours is x. Let's go back. Distance covered by car number 1 in 2 hours. 50 miles. Very good. Times dx over dt. But dx over dt is 25. And then plus y, the distance covered by this, which is in 2 hours. 120, very good. 120 miles times dy over dt, which is 60. Very good. Excellent. Everything divided by the square root. We already determined x to be what? How much is x? 50. So squared plus. We already determined y, which is 120 squared. I plug in everything in the calculator. Don't waste your time. Be very careful with parentheses. Let's do this together, please. Parentheses around the top. And we have 50 times 25. And plus 120 times 60. By the way, before I put in everything, what type of number do we expect? Is the distance increasing or is the distance decreasing? Do I expect an answer that is positive or negative? They're moving away from each other. Of course, the rate of change will be positive. Divided by, and the square root. You know me, I have to have parentheses, although it may not be necessary with the software or with your sophisticated calculators, but I'm not sophisticated myself, so I have to check these. Okay, good. So the answer is 65. Without a measurement unit, it means nothing. I mean, I shouldn't say it means nothing, but almost nothing. Miles per hour. This is the rate of change of the distance. So when the two cars are moving away from each other, one going south and the other one going west, the rate of change between those two cars is changing at 65 miles an hour. Any questions?